Hello and welcome to another science video by Johnny. So in this part, we're doing a bit of physics now, shall we? With Mr. An. And this is learning activity 4.1, applying static electricity. So we are doing a bit of static electricity now. And Mr. An, can you tell me what static electricity is, or static electricity is?
Static electricity it's basically like
Yeah.
a balance of charge of charge electricity.
A balance of charge electricity, yeah.
Imbalance.
And then so basically when you touch that place, what would happen? If you touch a place with static electricity, what would happen? Would you disturb that balance? I mean, it's an
Just like
imbalance, did you say?
yeah,
So when you touch that, you actually are taking away like the amount of extra things in there, right? So it starts to okay, so we're doing static electricity magic tricks now. Can you read it?
yeah. Choose at least 3 of the following 5 magic trick to complete by pressing on the tab. Each experiment
For
after
each
completing them try
experiment, after completing them. Mhm.
or electron moving to create the static. Feel free to conduct additional research as needed. Experiment 1. Lightning in your mouth. Material needed: wintergreen lifesaver, thick blanket, or completely dark room. Mirror. Instruction: go into the dark room for under a thick blanket where it's completely dark, and wait until your eye adjusts to the dark.
Mhm.
Back down on wintergreen candy with
With your
your
mouth
mouth.
open. Like
Can you explain what's
that.
happening? So,
This is one of the few times you should chew with your mouth open, like that. But normally you should not chew with your mouth open because it's so impolite. It looks gross. But in this experiment, you just have to chew like that candies. Wow, never know it could create a spark. I never tried this one before. So when a candy is crushed, electrons are pushed out of molecules, and it basically creates a spark, small little spark inside of your mouth, similar to an electrical charge buildup. Interesting. And an
observation is when you bite
nearby
your lips.
lifesaver. It's called it's a candy. It's called lifesavers. The candy spark and glitters as you chew like. It's like the color and the light just flash out a little bit as you chew. Interesting. I've never thought it would be that way.
Experiment 2. Swinging cereal. Material needed: piece of cereal, something with a hole in it like a Cheerio. Balloon, thread, small piece of tape. Instruction: tie a piece of cereal to one end of a 12 inches piece of thread. Find a place to attach the other end with the tape so the cereal does not hang close to anything else. Middle of the doorway or from the middle of a shower curtain. Inflate the balloon. Charge the balloon by rubbing it on dry hair several times, or vigorously rub it on a wool sweater or a piece of fabric. Slowly bring the balloon near the cereal. It will swing to touch the balloon. Hold it still until the cereal jump away by itself. Now try to touch the balloon into the cereal again. Observation: The zeros swing away from the balloon. They do not touch. The, the balloon builds up electrons, creating a negative charge from rubbing against hair or the wool. At first, when you bring the balloon and the zero together, the negative charge in the balloon and the positive proton in the zero attach. Once they touch, some of the negative electrons from the balloon transfer to the zero.
Balloon just
Now
touch it
they
like
are
this,
both,
just touch it like that. It produces a lot
yeah,
of electric charge on a balloon, and then of course it will attract things just like magnets. I tried it before. It actually worked. You can do the same with like nylon bags like this, and then you just basically squeeze it a bit, and then it will be able to attract like small pieces of paper.
experiment 3, bending water, material needed, plastic calm, sing with faucet and water. Instruction 1. Turn on the faucet so the water runs out in a small steady stream about 1/8 inch thick. Charge the comb by running it through long. Try hair several times or rub it visually on a sweater or piece of fabric. Slowly bring the comb near the water. Observation. The stream of water bent toward the comb. Comb become negatively charged when it's rubbed with hair or fabric. It attached the positive charge in the water stream, causing it to move closer to the comb.
Mhm. Okay, now experiment number 4, light bulbs inflated balloon. Diagram a thick blanket to create completely dark area. Create.
Inflate dark room with thick blanket to create a completely dark area. 1. Take the light bulb and balloon into the dark room. Charge the balloon on your hair, a sweater, or blanket by rubbing it quickly.
Make sure to build up a lot of charge for the experiment.
Touch the charged part of the balloon to the light bulb and watch very carefully. Experiment with touching different part of the bulb. Observation: the light bulb spark. The balloon becomes negatively charged when rubbed with the fabric hair. The built-up electron travel into the light bulb when they are touching, giving it a small amount of energy and thereby lighting it.
Mhm.
So it's like you rub the balloons
Rub it.
like yeah, and then you just like put in the light bulb and just like
And
it
of course,
gives
it
a bit of
gives
energy.
the light bulb some electricity. It gives the light bulbs flow of electrons, which is electricity.
Yeah, but not a lot because
Of course, not a
It is
lot. It's
very
not
little.
enough. It's not enough. It's just enough for like a spark or something.
Experiment 5. Material needed: inflated balloon, piece of wool fabric, stopwatch, clock, or timer. Blow up the balloon and tie off the end. Rub the balloon on the scarf or fabric once. In one direction, hold the balloon up on the wall. Start the stopwatch or timer and release the balloon to stay on the wall. If not, stop your stopwatch and write 0 second. In your data table, see
Hmm.
page 2.
Until the balloon stick to the wall. So once it stick to the wall, it means that the amount of charge is good. It's large enough for it to attract the wall so much, you know.
Look to a metal object. It should discharge any extra electron in metal. Touch step 2 to 4. Increase the number of rub each time until the balloon stick to the wall. When you increase the number of rub, do not rub the balloon back and forth. Rub the balloon in the same direction each time.
Mhm.
When the balloon does stick to the wall, keep the stopwatch going until the balloon falls off of the wall. When it does, stop the stopwatch and write time in the data table next to the matching number of rubs. Continue increasing the number of rubs
Rubs each time
each
the corresponding
time.
amount of time the balloon sticks to the wall with the stopwatch. Write the result in
Write the
in a
result.
table each time. You have to count number of like rub 2, 3, 4. It's like that.
Yeah, weird.
Okay, it will
The
become negatively
balloon
charged by rubbing with fabric or hair. The more it's
or
rubbed,
it's right.
the stronger the charge
More.
is, causing it to stay on the walls longer. Which
So it's
makes
like,
sense.
yeah, because when you giving it
More and more
electric,
electrons, so it's like it
yeah,
become stronger, and then it would take longer to discharge all of those electrons away, right?
charging material. How did you do in this in the previous segment? Let's go to into the detail of static electricity. Recall that an atom has positive nucleus composed of proton and neutron, surrounded by moving electron, which are negative. For instance, in the following board, Rutherford model, we can see an atom with no with two protons and two electrons. Since the number of positive charge equal the number of negative charge, this atom has a neutral charge. Proton and neutron are held in place by strong force, but the electrons around the outside of the atom are moving. Uh, this means they can be easily transferred from one object to another, or carry along wires or conductor. Static electricity results from the buildup of electron on the surface of an object. When two different materials come into contact, electrons can be transferred from one to the other, causing an imbalance in charge between the material. An object can become charged in one or three ways:
3 ways.
friction,
1 of 3 ways.
contact, induction. We will discuss each of these methods in detail. Charging by friction. Friction occurs when two objects made of different material visually rub against each other,
Mhm.
just as your sock against a carpet. One object gives up electron and the other gain electron. That has giving up electron now has a positive charge. And the object that has gained electron now has a negative charge. When you drag your feet across the carpet, you
Mhm.
gradually gain electron from the carpet, giving yourself an overall negative charge and leaving the carpet with an overall positive charge. If you were to shake someone's hand at this point, the exit
The
electron,
excess electrons would discharge from your body to the other person, giving both of you a shock. Chow! It's like that. Weird, isn't it?
yeah,
But normally you would have to open doors first, right, before you meet each other, right?
yeah,
So
but
if you go from door to room, and when you touch the anything, it will give off that charge to that object first. So unless you are rubbing your feet on the carpet and your office is basically in directly facing the customers, you don't have to open doors or anything, and you just stand up and then shake hand, then immediately, ow. Mm-hmm. Well, it's not a very nice experience, especially during winter. You have that a lot. Oh my god, winter! I remember always. Ouch! Especially when it
static
comes to
elect-
your clothes. Your clothes, your
yeah,
jacket, your fur coat or whatever. It attracts a lot of the static electricity thing, and when you touch it, it's just weird. Not that nice, to be honest.
charging by contact. Objects do not have to be rubbed against something in order to become charged. They can also receive charge by just being touched once by a charged object. This is called charging by contact. This behavior can be experimentally demonstrated using a device called
Electroscope.
electroscope.
Scope means to watch, to see. Electro means electrons. Or electricity. Like the device to see electricity. Electroscope.
Is something like that?
Well, people always think of something like that, we can always invent new things. Let's read more.
Electroscope, neutral.
Hmm.
An electroscope is an instrument for detecting pressure
Of static
of
electricity.
static electricity.
Of static electricity. Okay, they are made of a number of different designs. We all have one thing in common. They can have two parts, capable of moving like independently of one another when they're electrically charged. You can make your own. Huh? using everyday material. A large metal paper clip. Paper clip, uh-huh. Two more
Yeah.
small strips of aluminum foil, piece of cardboard, and a way to suspend the paper clip and foil. So the foil strip can hang down and move freely. Uh-huh. Just read down there, please.
You can explore how an electroscope works by making your own version at home using simple, everyday material. All you need is a large metal paper clip, and two small strips of aluminum foil, a piece of cardboard, and a way to suspend paper clip.
And foil, so the foil strip can hang down and move freely.
The following diagrams show the setup and example of the tin metal. Charge offset, cardboard, metal clip, strip of aluminum foil, glass jar.
Let's take a bit of break, shall we?
Yeah.
Alright, so electroscope, a homemade electroscope in an uncharted state. Mm-hmm. The two strip aluminum foil are threaded onto a bent paper clip. Okay, so that's a paper clip that has been bent. Okay. And allowed to swing freely, just freely. If the top of the paper clip comes into contact with a charged object, the two strips of foil become charged too. So it's like you transmitting it. It
Yeah.
moves to something else, transmitting it. Interesting.
Charge. Electroscope charge. When the charged object touches the top of the paper clip above the cardboard, electron can move between the object and the paper clip. If the object is negative, electron flow into the paper clip. If the object is positive, electron flow out of the paper clip into the object. Paperclip is attached to the foil strip so the electron can either flow out of the foil strip or flow into them. The flow electron make the foil strip in the electroscope positive or negative. In either cases, they are now charged in the same way. Remember the law of electrostatics. When two objects have the same charge, they repel each other, as
Mhm.
shown in the diagram. A homemade electroscope in the charged state, the aluminum foil strip bend apart. When charged, the charge comes from the object touching the target. By contact. Electroscope charging by contact. Let's take a look at an example. Charged object such as a plastic ruler rubbed against wool. The contact between the negative charge ruler and the electroscopes cause electrons to be transferred from the ruler down to the foil strip. When the foil strip get charged, they bend apart. When the ruler is removed, electrons from the ruler are trapped in the electroscope.
Mhm. Charging by contact, just touching each other, and then you basically get a charge because the charge
Yeah.
eventually will flow to another object.
Grounding. Electroscope grounding. To return to the electroscope to its neutral state, you can touch the top of the paper clip with your finger to get rid of the charge. The foil strip will then return to their resting position. Why does touching the telescope get rid of the charge? Process called grounding. Electrons carry through a conductor, in this case U, into the ground or the earth.
Grounding. Basically, when you touch the ground, the excess electron will just flow to the ground, and so when you touch the object, you will not get ouch. Will not get static electricity. Static electricity is really annoying, so that's why people do grounding.
Yeah.
Mhm.
Charging by induction. The negative will repel the electron at the tip of the paperclip, driving them into the foil. This makes the tip positive and the strip negative. Lower part of the electroscope become negative, electron flow into your finger. Lower part of the electroscope become neutral when the electrode is positive.
Java in induction. Lower part, electroscope become negative, and then what else? Electron flow into your finger when you touch it. Lower part electroscope become neutral again, and then so of course negative will kind of repel each other. So once your finger touch it, all negative charge flow to your finger. So the whole thing become neutral again. Lower part of the electroscope become neutral. And so what happens here? It's the positive charge of the upper part will start flowing equally to the rest of the electroscope. So the lower part, the whole electroscope, it's positive again. That's what it means. Charge don't just stay in one place. They try to, spread, right?
Yeah.
Mm-hmm.
When the negative charge ruler is brought too close to the top of the electroscope, it repels the electron in the top of the paperclip and push them down into the foil strip.
Mm-hmm.
This makes the strip negative so they move apart. When you touch the foil strip with your finger, the electron leave the foil strip and are transferred to you. Now the foil strip are uncharged so they move back together.
True.
Plastic ruler never touched the paper clip, so no electronics ran to the electroscope. All that happened was the electroscope within the electroscope were pushed downward. Your finger then took those electronic waves, so overall the electroscope was become positively charged. When you move the ruler and your finger away, the positive charge was concentrated near the top of the electroscope. It's allowed to spread through the paper clip and down into the foil strip. The strips are usually now both positively charged and therefore repel each other without touching the paper clip. The ruler has cause or include a charge that form on the electroscope. Charging material activity used the following simulation here.
The wall itself remains neutral, or because it hasn't lost or gained any electrons, they've just been prepositioned. And also the wall itself is connected to the ground, so it runs any excess electrons through it. So when you touch the wall, you're gonna get like, ouch! Static electricity, you know. Terrible to have that. Okay, charging material. Right, so we are now at another page now. Wow, look at that sweater. It's all positive charge now. And when you touch that thing, it gives a lot of negative charge to it. Isn't it?
Yeah.
And maybe you haven't touched enough. So now everywhere is supposed to be neutral.
Just like
Maybe you're supposed to rub it, like
yeah.
like that. I think. Not so sure how you're supposed to do this one.
So it's just like it's showing you how to like
It's weird. Sometimes this illustration doesn't work. It's supposed to be transmitting, eh? Isn't it?
yeah.
And you know what? Let's just move on. Sometimes the illustration doesn't work. Sometimes it just. Oh. Balloon and static electricity simulation. Accessible. Oh, sorry. Accessible version of balloon and static electricity simulation. The simulation shows a white wool sweater, a yellow ribbon, and a white wall. Can you just read that, please? Hello? Anne, are you there?
Yeah.
Okay, can
Yeah,
you
I'm
just
here, I'm
read
here.
that, please? Can you just read that?
I'm just reading. I'm just reading.
Mhm. I'm rubbing my hand now on Vaseline because I have dry skin. But probably I am transmitting a lot of electrons and proton as well. Probably
Yeah.
I'm doing it.
If you ever done this, you know how the balloon doesn't stick to a wall permanently. Can you give an
Mm-hmm.
idea?
I will
Or
explain this. Eventually, the electrons will deplete. I mean, just go to the wall, and then eventually you have no longer any walls, right? You have no longer
yeah.
electricity, have no longer electrons to keep the thing stick to the wall, and that's the end.
Just rubbing off one material against another where one material become negatively charged and the other positively charged. So this is friction.
You are right, and then they say you are right.
Yeah, so that you have a basic understanding of static electricity, explore how electrons flow through different material. Material are classified as either conductor or insulation, insulator. When it comes to how electricity moves through them, an electrical conductor allows electrons to flow through it easily. A conductor also gives up its electron more easily. An insulator, on the other hand, block the flow of electrons and tend to hold on them. Static
Hold
electricity
on, no,
requires
need to hold on them. It's like that.
Static electricity requires the buildup of electrons in objects, and therefore the type of material involved in static electricity are also
Insulator.
called insulator.
Hmm. Including a cone, paper balloons, and wall. How can you determine if a material is a conductor or an insulator? Hmm.
Example: conductor and insulator: aluminum, stainless steel, iron, copper; cardboard,
Cardboard,
wood,
wood, plastic, rubber.
plastic, rubber. Experiment: this is a simple experiment in which a circuit is sprayed with power source and wire that end in alligator
Alligator
clips.
clip, like alligator clip, like clip that you can just, like clip that look like an alligator.
Yeah.
Now, okay, power source and wire that end in alligator clip. About light bulbs connect to the circuit. And the circuit is left open, so the bulb does not light up at first. Okay, only when a conductor material is attached to alligator clip to complete the circuit does a light bulb get enough electron to glow. Hmm. So you can see which material is actually insulating, which material is not.
Yeah.
Mhm. If the material is attached to alligator clips and the bulb does not light up, of course it means the material does not conduct electricity. So the material is an insulator. So of course all the thing on the right, cardboard, wood, plastic, rubber, they are insulators. Oh, today I work a lot.
Starting the lab report. power source, wire, light bulbs, light tips, observation,
Mhm.
observation and receive.
Electricity passes through some material easily. The material called conductors. So they conduct electricity. So they are conductors.
Yeah,
And the opposite is like material that electricity can pass through. That is insulator.
insulator.
So they insulate. So they insulate things. So things can get through, cannot get through.
Yeah.
So we have material like they prevent heat from getting out in winter time of houses. Is that those materials also called insulators? Like for example, wounds are like wool or animal fur, something like that. These are insulators too. They prevent heat
Yeah.
from getting out. You also have soundproof materials for studio, for example. These are also insulators. Normally, if they insulate one thing, they can insulate other things too. Like for example, light, sound, electricity, heat. Sometimes they can insulate a lot of things.
Mm. So, analyst. The metal where the best conductor electron can flow through easily.
Now, analysis and conclusion. Enter your analysis and conclusion to the space provided. The metal,
Yeah.
one of the best conductors. Of course, they are the best conductor. Never touch a metal wire. That would be your worst mistake.
Yeah.
Electrical flow more easily through material, causing a light bulb to turn on. The non-metals were poor conductors, like carbon, nitrogen, oxygen, all those things. Non-metals are poor conductors because electron cannot flow easily and therefore cannot complete the circuit when placed within two alligator clips. Ebonite. I don't know what it is. Plastic food wrap.
Yeah.
Plastic food wrap actually insulate heat very well, so that's why it keeps the food warm. It also it's plastic, so it doesn't conduct electricity. So when you touch your food, you won't get like ah, you know.
Yeah.
But well, the main thing is to keep the heat in there, so they're the best insulated. Polyester, polyester contain like our clothes. Polyester clothes, synthetic rubber like rubber gloves, latex, latex gloves, acetate what? Acetate, cotton, paper, silk, fur. Actually, we use them in fur coats. But sometimes they do conduct some electricity, so that's why you have static electricity, in winter time. They just, when you touch them, it's just like you feel the electricity flow. But they are not
Yeah.
exactly great with electricity conduction, so that's why they're in the middle. Nylon, of course, human hair conduct electricity quite well. That's why
Yeah.
you like, sha. hmm
Well, so the material would give off electron.
Electrostatic series. Worse.
Yeah.
Wait, glass. Actually, glass doesn't conduct electricity. I'm sure of that. But then glass, they conduct heat quite okay. Because when you have a hot glass of water, it conducts heat quite well. But I'm not so sure why glass is worse conduct insulator of electricity. Weird.
Yeah.
Maybe they put it the wrong way. I would put glass around like paper glass, something like that. Silk paper glass. Uh-huh.
Paper glass. Lightning.
Mm-hmm.
Lightning. The friction of water, droplet, and ice pellet collide inside a storm cloud.
Causes lightning. Storm cloud have strong updraft. When a cloud that rise vertically in cloud, like just go up, updraft. The winds that blows like go up in cloud.
Yeah.
This wind carry lighter particles upward and leave heavier particles near the base of the cloud. So basically, because of these kind of winds, the heavier ones at the base of the cloud, but the lighter one are on top. So the lighter particles gain electrons, and the smaller particles, which is up there, loses electrons, become protons.
Yeah, proton.
So as a result, the top of the storm cloud become positive and the bottom become negative. So what will happen here is eventually the negative and positive thing will attract each other and cause lightning. Mm-hmm.
Positive charge to include on the surface of the Earth
Induce
just below
induce
the
on the surface of the earth.
direction of water. Lightning can also happen between the negative bottom and the positive top within the cloud, or between a giant cloud. The lightning discharge usually travel upward or sideways, cloud to cloud. Lightning is also known as heat lightning or sheet lightning. It is often seen in the distance, usually after the storm has passed. What makes lightning so dangerous? Cloud to ground lightning can strike anywhere in its path, and it takes the furthest route to the ground. The effect of lightning can be felt after the shock occurs. Trees have been struck and catch fire. Power surge can damage appliances in home, businesses. And if lightning strike a person, it can result
Severe
in
burns and even cardiac arrest. So basically, your heart can stop beating if you got struck. Basically, that is so mild to say. Basically, when people got struck by lightning, you're dead. Most likely dead. Because it's like 1 million volt. It can
what
be
are
up
the
to
chances?
10. It can be up to 10 or 1 to 10 million volt of electricity. So
Yeah.
very, 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 very strong.
What are the chances that you get struck by lightning?
The chance increases if you are not in the city. Because in the city, there are tall buildings, so the tall building will get it first, of course. Well, but you're out in the field, no, nothing taller than you, then the chance is very high.
Yeah.
Depends on where you are. I can tell, but there are some story of people surviving lightning and then they can develop the special abilities. Weird, but a lot of people they just died. So don't risk it to become a genius. It's not a good way to die.
Yeah.
Not a good way to
On
become a
top,
genius. Hmm.
so I think it's like usually in like skyscraper or
Uh-huh. They have skyscraper. They have these kind of electric, what's it called?
lightning
Poles.
rod.
Lightning rod, yeah. Lightning rod to attract lightning. So the lightning won't hit other places. So the lightning rod will eventually comes to the ground, and so it's grounded, so it doesn't damage anything.
Yeah.
So it like provide protection for other buildings around it or the other people.
Application for static electricity. In this part, you will research example of direct and indirect application for static electricity. For that, we suggest you write job notes. To avoid paint from being sprayed everywhere, spray paint is giving a chance that leaves
A
marks.
charge, a charge.
A charge, yeah.
essentially the nozzle of the sprayer. Psst, psst, psst. So spray plant is given a charge as it leaves the nozzle of the sprayer. If the paint particles are positively charged, they repel each other. So of course they will spread. So the surface on which they are being sprayed has the negative charge, so they attract each other, creating an even coating of paint. So less paint is lost to the surrounding. Because they are attracted to each other, so they won't go anywhere, you know.
Yeah.
So they go where they're supposed to go.
Application of static cells. So it's like they make use of the same principle as a furnace air cleaner, but on larger industrial scale. They are used in smokestack of metal ore, smelter, and power plant that burn coal. A high charge conductor causes particle in the waste gas to become ion of the same charge.
Mm-hmm.
Ions are repelled to insulated side of the pacificator. Once the ions are neutralized, they are collected as waste liquid and solid and don't end up in air, reducing the level of air pollution. Yeah. Fabric softener and dryer sheet. Tumbling action causes fabric to transfer electrons through friction.
What's that?
Photocopies. Copiers.
Okay, just read it first.
Yeah, you strive power that stick um, to
Sticks the
paste
paper to make a copy of
to
an
make
image or document, and ink in a photocopier to is a dry powder called toner. You know, the toner is basically when you take out from the printer, that piece, that huge piece is called toner, and inside of that you have ink particles. After a while of usage, you have to replace that, of course. The toner is given a negative charge. Oh, I don't remember the last time I used my printer.
probably a long time ago.
I mean, I don't bring much. I'm using my iPad to look at things now. I don't write down things anymore, so maybe I should do that. Maybe I should practice writing things stuff. Selenium drum. Part represent the words and picture in the document. There's a drum and toner on scroll over the sheet paper. Tone is transferred to paper exactly as it was in original. But it depends a lot on the quality of the ink, of course. But it's supposed to transfer exactly as in the original. Because sometimes when you print them out, the quality is not that great. It's not exactly the same, right?
Yeah.
I'm not so sure if I can. Of course I can. If I take pictures of things, maybe if I take pictures of like lyrics, I can just use my iPad to write on that picture, I think. Hopefully. Not so sure, I've never tried before. So I can work on it. Never tried things like that before. Let's try it. Okay, and then now. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh để đăng ký kênh đó, để mà các bạn có thể được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.